The sun is up, the sky is blue, today is beautiful, and so are you. Good day, everyone. We are the Group 1, and we were assigned to discuss Chapter 5 entitled Volcanic Hazards. And here are the reporters of this group. So let's start off with defining what a volcano is. A volcano is an opening in the Earth's crust through which lava, volcanic ash, and gases escape. Volcanoes can be exciting and fascinating to watch because of their natural formation, but they can also be dangerous. Any kind of active volcano is capable of creating harmful or deadly hazards, whether during an eruption or a period of quiescence or inactivity. So understanding what a volcano can do is the first step in mitigating volcanic hazards. However, it is noteworthy that even if scientists have studied volcanoes for decades, they do not necessarily know everything about what they are capable of. Volcanoes are natural systems, and they always have some elements of unpredictability. Just like in our country, the Philippines, we have Mayon Volcano and Taal Volcano to mention, which are some of the active volcanoes that we have in our country. But don't you know that these active volcanoes that we have may lead to hazards? So if this hazard becomes active, then it will literally endanger human lives and property. So by knowing the concept of what volcanoes can do, will give us insights on how to mitigate them. So moving on, a volcanic eruption is when lava and gas are released from a volcano, sometimes explosively. And here's an image of the Anak Krakatoa volcano from Indonesia erupting last July of 2020. Now let's move on to our main topic. What is a volcanic hazard? A volcanic hazard refers to any potentially dangerous volcanic process that puts human lives, livelihoods, or infrastructure at risk of harm. Several hazards may affect the area around the volcano, such as lava flows, pyroclastic flows, lahars, and landslides or debris avalanches. So now here are the different volcanic hazards.
Pyroclastic flows. Pyroclastic flows contain a high-density mix of hot lava blocks, pumice, ash, and volcanic gases. They move at very high speed down volcanic slopes and typical following valleys. It consists of two parts, a lower basal flow of coarse fragments that moves along the ground and a turbulent cloud of ash that rises above the basal flow. A pyroclastic flow is a dense, fast-moving, solidified lava pieces, volcanic ash, and hot gases. It occurs as part of certain volcanic eruptions. A pyroclastic flow is extremely hot, burning anything in its path. It may move at speeds as high as 200 meters per second. Pyroclastic flows form in various ways. This photo is from the eruption of Mount Pinatubo in 1991. Different ways pyroclastic flows form. Collapse of eruption column. During a highly explosive eruption, the column ejected upwards into the atmosphere cools and can become too full and dense to maintain upward momentum. Rolling over from eruptive vent. During an explosive eruption, material is erupted without forming a high plume and rapidly moves down slope. Collapse of lava domes or flows. The fronts of lava flows or domes can become so steep that they collapse due to gravitational force.
Volcanic gases. Magma contains dissolved gases which provide the driving force that causes most volcanic eruptions. As magma rises towards the surface and pressure decreases, gases are released from the liquid portion of the magma and continue to travel upward and are eventually released into the atmosphere. Large eruptions can release enormous amounts of gas in a short time. The 1991 eruption of Mount Pinatubo is thought to have injected more than 250 megatons of gas into the upper atmosphere in a single day. However, even if magma never reaches the surface, gases can often escape continuously into the atmosphere from the soil, volcanic vents, fumaroles, and hydrothermal systems. So this is a photo showing clouds of gas and hot ash burst into the air, and flowing lava gushed out of the Mount Pinatubo volcano after 600 years of dormancy. Harmful effects of volcanic gases. By far, the most abundant volcanic gas is water vapor, which is harmless. However, significant amounts of carbon dioxide, sulfur dioxide, and hydrogen halides can also be emitted from volcanoes. Depending on depending on their creations, these gases are also highly hazardous to people, animals, agriculture, and properties. So these are the harmful effects of volcanic gases. Carbon dioxide trapped in low-lying areas can be lethal to people and animals. Hydrogen sulfide is very toxic in high concentrations. Sulfur dioxide is irritating to eyes, skin, and respiratory system. Hydrogen halides are toxic acids.
Now we are gonna tackle about lava flows. Lava flows are streams of molten rocks that pour or ooze from an erupting vent. Lava is erupted during either non-explosive activity or explosive lava fountains. The speed at which lava moves across the ground depends on several factors, including type of lava erupted and its viscosity, steepness of the ground over which it travels, whether the lava flows as a broad sheet through a confined channel or down a lava tube, and 4. Rate of lava production at the vent. When magma erupts from a volcano, as pressure release gases dissolve in the magma bubble out, so the composition of lava changes hazard. This is an example photo of lava flow in Mount Krakatoa that has spitted streams of molten rock. Devastating effects of lava flows. Lava flows may instigate other types of hazards. Everything in the path of an advancing lava flow will be knocked over, surrounded, buried, or ignited by the extremely hot temperature of lava. When lava erupts beneath a glacier or flow over snow and ice, meltwater from the ice and snow can result in far-reaching lahars. If it enters a body of water or water enters a lava tube, the water may boil violently and cause an explosive shower of molten spatter over a wide area. Methane gas, produced as lava burst vegetation, can migrate in subsurface voids and explode when heated. Thick, viscous lava flows, especially that those build a dome, can collapse to form a fast-moving pyroclastic flows. Other natural phenomena such as hurricanes, tornadoes, tsunamis, fires, and earthquakes often destroy buildings and agricultural crops and homes because of lava flows.
Ballistic projectiles. Volcanic explosions can propel rock fragments on ballistic trajectories that may differ from the wind direction. These are known as ballistic projectiles. Ballistic projectiles are rocks that an erupting volcano may hurl into the air. These rocks and bombs travel like cannonballs and usually land within 2 kilometers of the vent, but can travel as far as 5 kilometers or even further if the eruption is very explosive. These events may occur without warning and in the absence of a larger magmatic eruption. More typically, ballistic projectiles are limited to within about 5 kilometers of the vents. This image shows ballistic projectiles coming out of the volcano. Devastating effects of ballistic projectiles. Tetrafalls and ballistic projectiles endanger life by: number 1, the force of impact of falling fragments, but this occurs only close to an eruption. Number 2, loss of agricultural lands if burial is greater than 10 centimeters depth. Number 3, producing of suspensions of fine-grained particles in air and water which clogs filters and vents of motors, human lungs, industrial machines, and nuclear power plants. Number 4, carrying of noxious gases, acids, salts and close to the vent, heat. And number 5, burial by tephra can collapse roofs of buildings, break power and communication lines, and damage or kill vegetation.
Signs of an impending volcanic eruption. The following are some of the observable signs volcanologists have identified when a volcano is about to erupt. Most volcanoes provide various types of warnings before eruptions begin, although an explosive eruption could occur without warning. Some premonitory events more likely will precede the next eruption. Steam blast eruptions could occur with little or no warning as superheated water flashes to steam. Magmatic eruptions, however, involve rise of magma toward the surface. Such an upward movement of magma normally will generate detectable earthquakes, may deform, may deform the ground surface, and may cause anomalous heat flow or changes in the temperature and chemistry of the groundwater and spring waters. People living near volcanoes may detect premonitory events before an eruption. Both the frequency and occurrence and intensity of felt earthquakes commonly increase before eruptions begin. Eruptions may also be preceded by noticeable steaming or fumarolic activity, perhaps by new or enlarged areas of hot ground. However, most precursorious changes are subtle and the most effective means of monitoring are instrumental and include a variety of geophysical, geodetic, and geochemical techniques. Seismometers are used to detect and locate earthquakes associated with the rise of magma. Swelling of the ground surface can be detected by using precision instruments and techniques that measure minute changes in slope, distance, or elevation of the ground surface.
Measurement of changes in heat flow. Other techniques involve measurement of changes in heat flow at a volcano by repeated infrared surveys or by direct measurements of hot spring or fumarole temperatures. Changes in the composition or relative abundances of fumarole gases may also precede eruption and can be detected by frequent or continuous analysis of gases. These and other types of monitoring may be useful in detecting warning signs of an impending eruption. Detection and interpretation of precursory events. The overall success of a monitoring system depends on detection and interpretation of precursory events in time to warn and evacuate people from threatened areas and to initiate other measures to mitigate the effects of the eruption. Although monitoring systems may be useful in indicating an increase in the probability of volcanic activity and its possible location, they typically do not indicate the kind or scale of an expected eruption, particularly the first magnetic event, the surrounding areas that might be affected. Precursors to volcanic activity may continue for weeks, months, or even before eruptive earth activity begins, or they can subside at any time and not be followed by an eruption. Thus, monitoring of volcanic precursors may provide general warning that volcanic activity in a specific is becoming more likely, but it often does not pinpoint the nature or timing of an eruption on when acting.
Interpreting different volcano hazard maps. The maps show different data and information by employing color codes and scalar illustrations. The following are the different volcano hazard maps.
This is the world major volcanoes map.
Major volcanoes of the Philippines, you have the Mount Pinatubo in Zambales, Taal Volcano in Batangas, Mayon Volcano in Albay, Canlaon Volcano in Negros Occidental, and Mount Ragang in Lanao del Sur.
Map showing pyroclastic flows from Mount Pinatubo. The Pinatubo volcano erupted in 1991 and produced an enormous deposit of hot ashes, up to 200 meters thick. In the years after the eruption, heavy rainfall in the area triggered large erosion and led to a series of lahars. Volcanic ash and pumice blanketed the countryside. Huge pyroclastic flows roared down the flanks of Pinatubo, filling once deep valleys with fresh volcanic deposits as much as 200 meters or 660 feet thick. The 1991 eruptions deposited about 6.83 kilometers of pyroclastic flows into different watersheds. The Sacobia watershed, which is the watershed analyzed in this exercise, starts at the eastern crater rim of the volcano and extends down slope until reaching down lowland Candaba Swamp and Manila Bay. The rapid erosion or removal of the 1991 pyroclastic flow deposit is one of the major social and scientific concerns after the 1991 eruptions of the Pinatubo volcano, as life-threatening and destructive lahars of enormous magnitude are generated. About 50,000 persons were left homeless by the lahars, and direct impacts such as flooding and isolation have affected more than 1.3 million people in 39 different towns and 4 large cities. About 1,000 kilometers of prime agricultural land are at risk.
Simplified hazard map showing potential impact for ground base. For the legends, the peach color shows the vent areas of explosive volcanoes, sources of lava and pyroclastic flows, thick tephra, lahars, ballistic ejecta, and rockfall. The red, orange, and yellow colors show the lahars. These are potentially far traveled in valleys draining volcano. The light brown color shows the regional lava flows. Lava flows from vents dispersed between major volcanoes. The dashed lines show the area adjacent to explosive volcanoes, subject to far-traveled pyroclastic flows and thick tephra. The volcanic ash, which is not shown in the map, are fine fragments of volcanic rock carried downwind. Map showing volcanic hazard zones. For the legends, pyroclastic flowage hazard zones. The first map shows the orange color shows the high hazard zones. The yellow-orange color shows the moderate hazard zones. The light colors show the low to negligible hazard zones. The small red circles show the eruption vent. The white circles show the ballistic projectile zone. The dashed lines show the ashfall impact zone. The red lines show the lahar path. The small black triangles show the peak or the summit. The blue lines show the river. The black lines show the road, and the black areas are the settlement. For the second map, integrated volcanic hazard zones. The red color shows Zone 1 or very high hazard. The orange color shows Zone 2 or the high hazard. The yellow color shows Zone 3 or the moderate hazard. The green color shows Zone 4 or the low hazard. The same with the first map, the small black triangles show the peak or the summit. The red circles show the eruption vent, the blue curved lines show the river, the black lines show the road, and the black areas are the settlement.
Simplified hazard map showing potential impact area for ground-based hazards. The hazards near the volcano are lava, pyroclastic flows, thick tephra, lahars, ballistic ejecta, and rockfall. The red and yellow colors represent lahars or volcanic mud flows. This is a map illustrating the hazards at the Ampato sa Bangkaya volcanic complex. The color red means high danger, orange is moderate, and yellow is low.
Precautionary measures before, during, and after a volcanic eruption. There are dangers that volcanic eruptions pose to people, so it is important that they know how to handle situations before, during, and after volcanic eruption to avoid serious problems. The following are precautionary measures before, during, and after volcanic eruption that may help save lives. Before a volcanic eruption, number one, be aware of the danger that volcanic eruptions pose to lives and be prepared to face whatever circumstances the eruption may bring. Number two, prepare all necessary things to bring once evacuation is needed. Those in danger zones are warned when to evacuate. Once given the signal, obey instructions. Refusing to evacuate will pose more serious problems. Number three, store as much food, water, light sources, and batteries that are very useful in case of emergency. Number four, volcanic eruptions have ash falls, so be prepared for masks or anything to cover nose and mouth. Number five, prioritize the safety of the children and the elderly before other things. Take them to relatives who are far from the volcano and let them stay there until volcanic emergency subsides. During a volcanic eruption, Number 1, avoid all low-lying places because lava flows and mud flows are more likely to pass here. Number 2, seek cover in case of pyroclastic falls and ballistic projectiles. Number 3, use mask and cover mouth and nose to avoid breathing in ashes. Number 4, if inside a house, close all doors and windows to avoid ashes from getting inside. Stay indoors. Number 5, if evacuated, stay in the evacuation center until further instructions. Do not attempt to leave the place unless told to do. After a volcanic eruption, number 1, check house and place if already safe. Number 2, clean everything around and check all damages incurred. Number 3, use mask while cleaning ash and other debris. Number 4, wait for further announcements related to the volcano activities. Number 5, make sure that house is still safe for the whole family.
And that's basically it for today's video. I hope you guys learned something from us, and thank you for listening and watching.